and whose radius in the y direction is 4. And you can kind of see that, right? 3, 3, 4, 4. Do you guys catch my drift here?
So that x squared over r squared is kind of like the equation of an ellipse, right? Versus the one that's...
So if these two numbers are the same, that means I have the same radius all the way through as a circle.
Yeah.
Versus an ellipse. Does that kind of answer your question in terms of... that being said, before they cut content out of Calc 2, I was supposed to teach you all about conic sections, which includes ellipses, hyperbolas, circles. And you usually spend a day and a half on it. I cut that. There's going to be some times where if we have some of those days where I called flex days in our syllabus, that if we don't use them, that might be something that some bonus coverage to get you guys like to kind of think through those things, but they won't be tested. Okay. Any questions on this example? Likewise, you guys, at any point, your graphing calculator can be a tool to help you graph these things, okay? So if we did x equals 3 cosine theta and y equals 4 sine theta, and make sure your t-step goes all the way, it goes from, your t-min needs to go from negative 2 pi to positive 2 pi. Why?
Yeah. Why can't we just do 0?
Oh, you could probably get away with 0. Hold on. Yeah, you can get away with 0. Yeah.
How do you know that you start at pi over 4?
It was arbitrary. If we could have gone 0 to... Now, what would happen is if, like, I made my t-step, I'll change it to... Let's say I was counting by pi over 2s instead of pi over 4. So by counting, the smaller that t-step, the more you can start to see the smoothness of the curve. I decided that pi over 4 was enough for you guys to see that it's kind of egg-shaped. Does that make sense?
Yeah.
Are we good? All right. So these examples where I gave you the graph, I asked you to graph it, and I asked you to go from a parametric equation into a rectangular equation. These next couple examples, I'm going to give you a rectangular equation and say, here's a parameter, let's write a set of parametric equations. The first round will be really, really easy. The second round you won't like. But it's fine.
It's like your mathematical career. First couple of years you liked.
All right, you guys. So my rectangular equation we're going to look at is y equals 1 minus x squared. We all kind of have a vision of what that equation looks like, yes? Okay, so first question. If I'm asking you to let t be the parameter that we care about, time, okay? And I'm telling you that t equals x is your first parameter. And our parametric equations look like, if t is equal to x, what's my x equation?
T is equal to x.
X equals t, great.
The y one would just be 1 minus t squared.
And the y one would be 1 minus t squared, and you're done. That's it. And for these examples, guys, let's go ahead and let our t parameters be negative 5 to 5, okay? Can you guys graph this in your calculator showing me the orientation, please?
What's our t step?
Just make it like, I don't know, 0.1's fine.
Parametric affect stats at all, so I just leave that calculator parametric.
No, we'll never graph, so it won't be a problem. It could become problems for you guys in physics. I don't know, do you guys ever use the y equals menu in physics?
I don't use it too much, but I think you'll remember when you see
Mm,
Y equals.
yeah. And you could turn everything, as you just saw, you can turn any rectangular into a parametric, no problem. Just let x equal t. All right, and you guys, hopefully you're seeing a graph that looks kind of like this, and it went this way.
Because you go from -5 to 5.
Yeah. Do we need help? Is anybody shocked to see the graph on your calculator look just like y equals 1 minus x squared? Okay. Now, sometimes we don't want to just set our parameter to be x equals t. Sometimes we want to be thinking about how are x and y changing with respect to something other than time. Okay? And so, in this next example, same equation, what I'd like us to do is think through how are x and y changing with respect to the slope, which feels a little bit weird, okay? Are you guys with me that the slope at any given point is equivalent to dy dx at that point? And you guys, do we know the value of dy dx?
We can.
I mean, we have the equation is y equals 1 minus x squared.
So if you dy dx is
Dy dx would equal? Negative 2x. It's the derivative, yeah? So I know that the slope is always negative 2 times the x coordinate. Yeah? So if I want to write the x coordinate with respect to the slope, what is x?
the integral of -2.
Oh no, whoa.
Wait,
If m is equal to negative 2x, I could divide both of those equations by negative 2
oh, I see what you're saying.
and say that x is negative about it. Every good?
I thought you were asking to turn it into something else.
And once I know that x is negative m over 2, what's y?
One minus
1 minus
the
negative m over 2, the quantity squared, or 1 minus m squared over 4. So, if I graph those parametrics, put those in for x and y, what happens? Do we get the same graph?
Yeah.
still practicing the variable
It's
feature.
mine like stops.
It stops.
It stops at different places?
Yeah.
No, it stops at the same place, like the same line.
There's one thing that should have been a little bit different.
Direction.
You guys, it should have started here. It should have gone this way.
Wait, I have to do that again to see that happen.
Mine did.
Mine looks like.
Wait, how do I get it to do it again?
That's what I did.
Is that also like
I don't know.
shorter?
Yeah, it starts the other way.
I would bet that it's shorter.
Yeah, it is shorter. I just have to like rewatch it. I wasn't even paying attention.
It should be a little bit shorter. But depending on what you set your y min at, you might not, if your y min wasn't set at the right place, it might not look as short. Right?
So you're gonna like stop your calculator from making the graph and go back to the y equals because like as it's drawing, it
If
doesn't
you-
let you click out of it.
If you hit, I want to say second and then the power button.
That's what I do. Okay.
I think it should do it. Second and then the power
Get
button.
it to draw again.
To get it to stop drawing. To get it to draw again, you need to go in, change the window, and then change it back. Okay. So, let's talk about this short for a little bit. Why did the direction change?
So you're doing
It's
the slope,
negative
and the slope is,
Because so you guys, as my parameter increases, what's happening to x? Well, in this one, as t is increasing, x is increasing. But over here, because my x is negative, as n increases, the value for x is actually getting smaller, right? Like if I plug in 10 versus 20 for m, when I plug in 10, -5, do you guys see what I'm saying? Because negatives count backwards, right? So here's m is getting bigger, x is getting smaller. That's why it switched directions. Why is it shorter? Because I'm taking all of those different values and dividing them by 2. Is everybody good? Okay. So how do different parametric curves affect orientation on the graph? Essentially, the x-coordinate, if it's positive, the graph's going to move right, or move from left to right. Do I feel comfortable with that? No, I don't. I don't feel comfortable with that. Because, like, if my x-coordinate were 1 over t, then as t increases, x would decrease. Yeah. So, like, you want to look for what happens to x as t increases. That's kind of your guiding question. That's going to tell you whether you're going right to left or left to right. And then when you're dealing with that sine and cosine, it's almost like, is your angle going up or down? Okay? All right. So in terms of your homework and your quizzes, these 3 questions are very, very similar to what I would give you. So I'm going to give you guys some time to kind of do these. And then I'll give you like 10-ish minutes, and then we'll come back and look at them together. I'm assuming we got a graph that looks something kind of like that. Never on the other side of that parabola, yeah? How come we never went to the other side of the parabola? Look at my x-coordinate. Is the square root of t ever going to be negative? So it's not even like even if t were negative, which it can't be, but even if t were, the answer to that square root is always going to be positive. So it's only the right-hand side. If you put that into rectangular form, you should have gotten that t is equal to x squared, so y is equal to x squared minus 5. Cool? All right, if we look at this one and I graph it, the graph should have looked something kind of like this. Yeah? And then, how do we do on getting the rectangular on this one?
I was confused. Like cubed x.
Yeah, that's by far the easier way to look at this, for sure. So, and then the orientation for this should have gone this way too, yeah. Okay, so, as I'm looking at that, if I try to get the t by itself, I would end up with t equals the natural log of x, yeah?
Yeah, that's what I tried.
Okay. And then what would happen is y would equal e to the 3 ln of x plus 1? No, plus 1 here, yeah? Okay. And then from there, I think this might be a push, like you wouldn't think to do it, but I would move that exponent up, or that 3 up on top of that ln of x. So now you have y equals e to the ln of x cubed plus 1. And there's a log property that e to the ln cancel each other out. And you've got y equals x cubed plus 1. However, and that's how I thought of it too, like, if you look at that y equation, you could think of that as y equals e to the t to the third power plus 1. And what do we know about e to the t? It's x, so that's y, and think of that as y equals x cubed plus 1 from there. Like, that's fine too. Whatever makes more sense to you is fine with me. And then lastly, this one, you should have gotten an ellipse that looked something kind of like this, like a tall skinny one with this. And then your equation should have been x squared over 9 plus y squared over 49 equals 1. We feel okay? Great, I'm done. It's Friday. Yeah.
How do we know what, like, the bounds should be?
On the tests and quizzes, before I print them, I'm going to go actually do it right now. Go and look through and make sure I tell you what the bounds on the parameters would be. If it's a theta,
Different graphs only have different bounds.
that's not...
Like, and then we change the bounds and then
Well, what's happening is you're not necessarily getting different graphs, you're getting different sections of the graph. Right? So, like, no matter what, like, this ends up being the graph of y equals x cubed plus 1. So depending on where your bounds are, you wouldn't have gotten the negative side of it, but you could have had, like, from here to here, or from, like, you could just have different sections, but you should end up with the same graph no matter what. But just different pieces of the graph depending on which t's got plugged in.